Hi guys, our project is to reduce the work of the psychiatrist. Where my project title is a unified multimodal framework for human like this project mainly uses three machine learning models named LSTM and SVM as well as the OpenCV, where we are using three ML models to predict the accurate emotion of an user and try to provide a better routine for him to follow for a certain number of weeks, and that brings him to back to the normal emotion. Where if it is not, then we can also recommend a doctor or some other psychiatrist they can able to reach out them and clarify what all are the doubts or what all are the problems they can facing now. And our problem statement is to currently a world like facing an psychology issue because the evolution of the mobile phones, most of them are gone into the depressed mode in the earlier stage. So we are focusing to bring back into their normal state as soon as possible, so before it going to worse. Okay, like first of all, we are using the multimodal analysis, namely the LSTM, that means long short-term memory. Like when compared to any other models, it can provide a better result for text-based recognitions. And SVM models mainly used to classify and voice tones to predict the emotion, and CNN to analyzing the human facial emotions and try to provide a more accurate result by comparing these three models. And we are taken multiple person as an example and try to find the better models to predict the human emotions. And these all are our literature reviews. And we are facing an issue issues are in the current world, every applications having single model analysis, so this mainly focusing on the single emotion like text or face or speech. So it may provide some less accurate emotions, so we are using multimodal emotions to provide the better accurate result. So we are overcome this issue with three machine learning models. And and the psychiatrist in this world is currently less. So instead of everyone visiting to get recommendation from an psychiatrist, we are bring back some of the earlier stage depressed persons into the normal state using our application. And the third main thing is when you are reach out to an psychiatrist, so you are facing the issue if someone think like I'm a mental or some other like that, so you are feel fear while visiting your psychiatrist. But when we are providing an virtual machine where it's an isolated environment, so you can free to speak into it. So this may provide an user to provide an accurate emotions currently they are facing. And we are challenges we are facing are the main challenges we are facing is the overfitting, where overfitting means model where perform well in the training process but not perform well in testing. So we are overcoming this using an the sigmoid activation function, where it may activate using an current data, it may updates the weight as well as the bias and try to find a better weight and bias to calculate the emotion for each. And also we are providing the data privacy by using an encryption methods as well as the bcrypt hashing like that. So if a user wrongly exposes their such as an Aadhaar card, PAN card, or some other ATM numbers. So we are using encryption and data breaches make happen. So it may they can't able to view the original or some sensitive information of an user. And also we are providing a more accurate system while using in three machine learning models. And these are all the challenges we are facing, and we are solving it using some other techniques. And proposed work where we are using LSTM model as I mentioned earlier. So LSTM models means like it's a long short term memory, where instead of comparing each model, we can provide a better accurate results. So I can provide an example, like when I'm saying uh, I want to suicide yesterday, but now I feel better. So each model can predict it as an bad emotion because there is a more negative sentence like as a suicide as an present in the sentence. Okay. So when comes to LSTM, like it may if find any negative sentence inside any negative word inside a sentence, it may keep it to an memory and try to iterate to an complete sentence and try to find any positive word that present that comes after the negative word. And if it is yes, then it may like replaces those negative word with a positive one and try to provide the better results uh, when compared to any other models. So we are using LSTM for text based recognition, and like the second thing is a SVM that mainly used to like classify in tone, because like when a person is feeling angry, then they always uses a high pitched tone, and if a person is depressed mode, then like he can speak lowly or like that. So we are classifying based on the pitch tone, and so that we are using SVM model to fix best fit line, and we are classifying the tone based on the pitch or the voice pitch the user and used. And we are trying to capture the image from an computer vision, and we are also trained a model to predict that pictures. Like we are capturing an multiple snapshots from computer vision through video, and we are analyzing each images to like analyzes an image and try to provide the better accurate results by passing it to a model which we trained. And after combining these models, we are like provide a final report that may like mainly concentrated both these three machine learning models. And if it is bad or some sad emotions, so we are providing the better routines, so the user need to follow it for some certain number of periods. So after following that, we are also conducting an some next session for an user to find any improvements they can face or not. And if it is not, they we can provide like the details for the psychiatrist, so they can able to reach out them to find the solution for them. And like this is our architecture diagram. First of all, we are need to provide the basic information of an user, and after that we are able to select the text and speech as well as the video based analysis model. And after completing these sessions, we can provide the reports as an final thing, where the reports may contain the basic information of the user and the results which was provided in the each sessions, and also the final report has been attached into one reports, and also the routine may be added. So based on that, we are providing our application into an uh, live. And these are all the system requirements where we are needed, so 8 GB of RAM system and processor, and the software requirements tools. These are the tools we are using to build this application into an uh, like um, the live model. And these are all the models we are using, like the login where user can provide the basic informations like name and age, and based on the age we are providing like asking a question for the user to recover answer from them. And the next we are using a text based recognition as the next model to predict the user's emotion based on the speech, the text which was they typed. And the next one is a speech emotion model where it mainly used to predict the emotion which the user can use it. And the video based recognition to capture the image of an user and try to analyze those image to find the better accurate result for them. And we are storing those information into a database model, so that may helps us to compare the last emotion which they faced and the current emotion. So only we can able to find whether any improvement the user can found or not, like that. And the dashboard contain the basic information of the users and like the results which was provided in the each sessions, and also the final reports will with and routines the user need to follow. And these are our like outputs pages, where this is an home page and this is a registration page, and this is a login page where this is the code which we like build. And like this is the database which we stored, so it will store the id number as well as the question with a response which was given by a user, and also an emotion which was predicted by a model for that particular answer which was provided by the user. And these are all the references which we take.